Okay, so we have a question here in 1.4, and some of these for you are going to be in different order, so I won't go over specifically which one it is, but this is about the bumping rate. Okay, where we're given a specific year. Here we've got 2000 to 2005, and these are the number of passengers in 10,000 that are bumped from flights. So in the year 2000, we have 21,000 passengers bumped. Year 2001, we have 18,000 passengers bumped. And we're asked to go ahead and graph that. Now, it says specifically from the year 2000. So what that means is we start keeping track in the year 2000. So the year 2000 becomes our 0, 2001 becomes a 1, and 2005 becomes a 5. So this represents the data fairly well. Now notice that the data is not, sorry for the bumping, I'm using my phone here, it's not forming a straight line, right? It's not linear, right? Linear means straight line. This is not a straight line, but it's close enough to being a straight line. We like to use straight lines because they're easy to deal with. And so we'll pretend things are a straight line sometimes in order to better deal with it, or deal with it in an easier way. So what we do is we draw a line that kind of sort of comes close to all of the data. So see this red line here, it comes close to the data. It's not quite right though. The data really doesn't fall on that straight of a line. We use those big dots to represent our data, well, because we have to use something. But those big dots really represent an infinitesimal point. So really, really, really small point. They're not that big. And most of that data does not fall directly on that line. So when the question comes up, okay, part C, what is the r-intercept of the model? Well, we're talking about the r-intercept, so where we cross the r-axis. Sorry, wrong one. Where we cross the r-axis, right there. Okay, and the t-value, time, is going to be 0 there. Okay, but we know that represents the year 2000. So how many people are being bumped in the year 2000? Well, we know from the data itself, it should be at 21, right? That's from the data. But we kind of had to make a compromise when we made this line and say, you know, not all of the data points fall on that line. So some of the real data isn't going to be on that line, but we can use that line to predict what's going to happen in the future. Okay? So there's a little bit of a compromise there. So with our new line that's a representation of our model, it really falls at the 20. It's closer to 20. So the answer becomes 0.20 instead of 0.21, whereas 0.21 represents the actual data. 0.20 represents our model that we've created. And it's kind of sort of close. It's not perfect. But again, we're going to use that to predict what's going to happen in the future, and we know it's not going to be 100% accurate, but we want it to be close. And sorry, this is really bumpy. Hope none of you have motion sickness and using it for my phone.